Hello everybody, myself Prashant Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. In electric machine tools, in the last class we have completed the synchronous machines, that is parallel operations of alternators and synchronizations and load division. Okay, so today we'll start a new unit or module, that is last module, unit 6. So this module particularly comprises of special electromechanical devices, principle and construction of switched reluctance motors, permanent magnet machines, brushless DC machines, hysteresis motor, stepper motor, and tachogenerators. So this unit actually whatever though we have studied so far, so any particular machine, so this is actually combinations of all these different machines for special purposes being used. So most of that there are lot many such type of special electromechanical devices are there. So mainly we will so discuss only about a few of them. So mainly principle and construction of switched reluctance motor, permanent magnet machines, brushless DC machines, hysteresis motor, stepper motor, and tachogenerators. So let us start with switched reluctance motor, its construction, working types and advantages. So switched reluctance motor is also known as variable reluctance motor, and this motor works on the principle of variable reluctance. So this means the rotor always tries to align along the lowest reluctance path, and as the name suggests, switching inverter is required for the operation of switched reluctance motor. So once again I am telling you, particularly this motor works on the principle of variable reluctance, and this means the rotor always tries to align along the lowest reluctance path, and as its name suggests, particularly a switching inverter is required for the operation of switched reluctance motor. So since switched reluctance motor works based on the variable reluctance principle, the rotating magnetic field is created with the help of power electronics switching circuit. And the main concept is the reluctance of the magnetic circuit is depending upon the air gap. Hence, by changing the air gap between the rotor and stator, we can change the reluctance of the motor. So see, this is reluctance versus air gap. This is stator and this is rotor. This is reluctance part. So whenever this gap is more, this is maximum reluctance. So if we go in this way, if rotor move in this way, so this will be reluctance path, reluctance will be minimum. So as it is, the rotor moves in this way, the reluctance is say reducing as per the rotor position. So see the rotor tilt, so actually see this is minimum. Okay, so this is the reluctance part. So reluctance versus air gap will be like this. And reluctance, you know, it is nothing but resistance to the magnetic flux. Opposes basically reluctance opposes the magnetic flux, and for electrical circuit it is resistance, and for magnetic circuit it is reluctance. We have studied so far. Now construction of SRM, switched reluctance motor. In switched reluctance motor, the stator and rotor have a projected pole made up of soft iron and silicon stampings, and silicon stampings is used to reduce hysteresis losses like all other electromechanical or electromagnetic devices like this. So this is silicon stamping basically reduce the hysteresis losses. And stator, either it is inward projections and rotor outward projections, and the rotor does not have winding and the stator only carries main field winding. So each winding in the stator is connected in series with the opposite poles to increase the MMF of the circuit. and it is called phase winding. So this is the figure of say this figure 1.1. A dash, B dash, and C dash are the phases. So this is the stator windings, and this is rotor. Okay, these are the phase windings. Okay, so pole concern, the number of poles in the stator will be around 6 to 8 numbers. But the rotor carries a smaller number of poles with respect to the stators, and the rotor poles will be 4 to 8 numbers. So by increasing the number of poles, we can get a low angle of rotation from the motor, and the rotor shaft is mounted with a position sensor. The position sensor is used to determine the positions of the rotor by a control circuit. Okay, and control circuit always collects the informations of the rotor position, and based on the controller gives the input to the motor. So this is the block diagram of switched reluctance motors. So this is SRM, this is input, this is converter circuit. So then basically this is the inverter. This is DC input, and we are getting AC output here. And this is the motor speed, which is a feedback. It is a feedback part, and it will go to the digital controller, and so the reference signal will be generated to provide the required output of this inverter circuit. So DC input is connected to the driver converter circuit, and the output is connected to the motor, and the rotor sensor's feedback wire is connected to the controller circuit, and it provides the position of the rotor with reference to the reference axis. So finally the controller collects all informations, and based on that reference will be given to the status, and also the controller monitors the motor current and protect the motor from internal and external faults. Okay, so the converter circuit is like this. So this is the converter circuit. So this is for the phase A, this is for phase B, and this is for phase C. And also note that the output of the controller is DC, particularly this, and the output will be as shown in like this figure. This figure. This is phase A. This is phase B, and this is phase C. Okay, so this is on state and this is off state. So this is the switching pulses, and how it works. So this is the switching pulse of SRM, and working principle of the switched reluctance motor is simple. And let us take an iron piece. If we keep it in a magnetic field, the iron piece will align with the minimum reluctance positions and get locked magnetically. The same principle is followed in switched reluctance motor. The minimum reluctance portions of the rotor tries to align itself with the stator magnetic field, and hence the reluctance torque is developed in the rotor. So this is actually SRM switched reluctance motors. So in our case, we consider the following notation for better understanding. For stator poles, A dash poles axis for A phase, and BB dash poles axis for B phase, and CC dash poles axis for C phase. And rotor poles, this is small A dash rotor poles axis for position 1, BB dash rotor poles axis for position 2, and C, this is shown here. Now the input is given to the A phase, and other B and C phase neither maximum nor minimum, and then stator poles axis A dash and the rotor pole axis A dash are in alignment. So this is the picture. So this is A dash is the stator poles, and this small A dash is the rotor poles. They are in alliance. Okay, it is aligned. Okay. Now this figure indicates that the F is reached the minimum reluctance positions. F is reached the minimum reluctance positions. This is actually the BB dash aligned with so this rotor axis BB dash, and this is CC dash actually. This is actually CC dash aligned with AA dash. Okay, so this is working. So because of the air gap between the stator and the rotor is very less, and there is a minimum reluctance position as compared with other poles, then torque actually say d theta LA equal to 0. This is the phase reluctance LA, and theta is the angle of rotation. So now pole and phase A will be turned off, and B phase is energized. Then the rotor axis BB dash turns to stator axis BB dash, and move clockwise as per our say diagram. By changing the polarity of the motor, we can easily reverse the motor. So the torque developed since the reluctance changes from maximum to minimum, and developed torque is equal to half IB square d theta LB. So the rotor movement is depending upon the number of poles, and in our case we get 30-degree rotation by energizing one phase at a time. Okay, so torque is nothing but a rotor movement only when the shaft reaches the position BB dash, then there is no torque. So d theta dlb equal to 0. See here actually. Okay, so basically now the B phase will be turned off and C phase will be turned on, and the torque is developed because the rotor axis is A dash is aligned with the stator axis CC dash, and then the torque is developed. Then the torque is developed because the rotor axis A dash is aligned with the stator axis C dash, and the rotor continues to rotate for another 30 degree. Again, actually, again C will be turned off and A will be started, and the motor operation continues until the input power supply. So you can observe that the motor is rotating by self. The switched reluctance motors are self-starting motors, and the control circuit continuously monitors the motor speed and input current. And if the motor speed falls with respect to the reference, then the control considers as there is a requirement of high torque. So therefore it increases the input current to the motor to meet the speed requirement, and in case if the motor current is reached beyond the spool load current, it trips the motor. So that is actually the operation and working principle of this switched reluctance motor. Okay, so now we'll talk about this types of switched reluctance motor. Based on the construction, the switched reluctance motor is divided into two categories. One is linear SRM and another is rotary SRM. So linear SRM is single step stator and rotor, and rotary SRM is more than one step stator and rotor. Okay, so this is the types of SRM. So switched reluctance motor, so rotary switched reluctance motor, and this is linear switched reluctance motor. In market it is actually servos, and this is actually radial field SRM and axial field SRM. So axial field SRM again single stack and multi stack. Okay, so these are the types. Clear? And advantages of SRM is it does not require an external ventilation system as the stator and rotor slots projected, and the airflow maintained between the slots, and rotor does not. The rotor does not have a winding, since therefore no need keeps the carbon brass and slip ring assembly. And since the absence of permanent magnet, such motors are available at a cheaper price. Simple 3 or 2 phase pulse generator is enough to drive the motor, and the directions of the motor can be reversed by changing the phase sequence. So self-starting and does not require external arrangement. So starting torque can be very high without excessive inrush currents, and high fault tolerance. Phase losses does not affect motor operations. High torque by inertia ratio and high starting torque can be achieved. But some disadvantages also are there of switched reluctance motors, and it's basically it creates torque ripples at high speed operations, and the external rotor position sensor is required. Noise level is high, and at a higher speed the motor generates harmonics. To reduce this, we need to install larger size capacitors. And since the absence of permanent magnet, the motor has been designed to carry high input current, and it increases the converter kVA requirement. And what are the applications of SRM? So applications of SRM, domestic applications such as in washing machines, vacuum cleaners, fans, etc. And let us to better understand the working principle, so carefully observe these animations of the switched reluctance motors here. That is here. See this animation. Okay. See how it is working. So how the rotor positions is being aligned with the stator positions, and it is rotating by 330 degree. In each step. Okay, observe it carefully, and you will find this rotor alignment with the stator alignment, and how its switch reluctance is getting operated. Okay, so I think this animation will help you to understanding of this operations of this switched reluctance motors. So once again, actually we'll repeat the entire discussions of today's topic of switched reluctance motors. I'm repeating it once again of the entire today's discussions. Let us come to the very beginning of the from where we have started the discussions of this switched reluctance motor. It's what is reluctance means, how this reluctance can be used to say make this motor actually. So this is actually, I'm telling you, it's a this switched reluctance means the motor works based on the variable reluctance principle, and a rotating magnet is created with the help of power electronic switching circuits that I have shown you. Main concept is the reluctance of the magnetic circuit is depending upon this air gap. Hence, by changing the air gap between the rotor and the stator, we can change the reluctance of the motors. You see, this is how this air gap is being changed, and with the help of this change with this air gap, the reluctance of the motor is being changed. Okay, so this is the reluctance versus air gap, from maximum to minimum positions presentations. And reluctance is like resistance in electric circuit, and reluctance is in magnetic circuits, which oppose the flux. And the construction is switched reluctance motor have a projected, the stator and rotor have a projected pole made up of soft iron and silicon stampings, and silicon stamping is used to reduce this hysteresis losses, particularly iron losses, and the major part silicon stamping is used, and stamping basically reduce the eddy current losses also. And stator is inward projection and rotor is outward projection. See, This is inward projections and rotor is the outward projections. And the rotor does not have a winding, and stator only carries main field windings, and each winding in the stator is connected in series with the opposite poles that is shown, and to create connected in series with the opposite poles to increase MMF of the circuit, and it is called phase windings, that is like AA dash, BB dash and CC dash of this stator winding. And I told you that rotor doesn't have any winding. Okay, so these stator windings are the phase windings, and this is rotors. These are the rotor axis, BB dash, AA dash. Okay, now pole concern, the number of poles in the stator will be around 6 to 8 in numbers, but the rotor carries a smaller number of poles with respect to the stator, and rotor poles will be 4 to 8 in numbers. So by increasing the number of poles, we can get a long angle of rotation, a low angle of rotation, sorry, and from the motor, and the rotor shaft is mounted with a position sensor, and the position sensor is used to determine the positions of the rotor by a control circuit. So the control circuit always connects the information of the rotor positions, and based on the controller gives the input of the input to the motor. So basically this is the controller. So this is input DC, this is the converter circuit, then it is AC, 3-phase AC, so this is provided with the stator with the SRM, and this is the motor speed which is being fed back to the digital controller and it being as a reference signal. So and it say trigger the converter circuits. Okay, so DC input is connected to the driver or converter circuit, and the output is connected to the motor, and rotor sensors feedback wire is connected to the controller circuit, and it provides the position of the rotor with reference to the reference axis. So finally the controller collects the information, and based on that reference will be given to the status, and also the controller monitors the motor currents to protect the motor from internal and external faults. So this is the converter circuit. This is for phase A, this is for phase B, and this is for phase C. And also note that output of the controller is DC, and the output will be like this is shown here. This is for phase A. This is on state, and this position is off state. This is for phase B, and this is for phase C. These are the switching pulses. So working principle of switch reluctance motor is simple, and say if we take a iron piece, if we keep it in magnetic field, the iron piece will align with the minimum reluctance position and get locked magnetically. The same principle is followed in the switch reluctance motor. The minimum reluctance portions of the rotor tries to align itself with the stator magnetic field, and hence the reluctance torque is developed in the rotor. So this is a picture of a SRM, switch reluctance motors, and for better understanding we say stator pole A dash poles axis for A phase, BB dash poles axis for B phase, and CC dash poles axis for C phase, and rotor poles is small A dash rotor poles axis for position 1, and BB dash small BB dash rotor poles axis for position 2. And now the input is given to the A phase, and other B and C phase neither maximum or nor minimum. Then stator pole axis A dash and the rotor pole axis A small A dash are in alignment, that is shown here. And that A phase reaches the minimum reluctance positions, whereas say this is the BB dash aligned with BB dash positions, and this is say CC dash aligned with A dash axis of say of the rotor. So because of the air gap between the stator and the rotor is very less, and there is a minimum reluctance position as compared with the other poles, then torque d theta LA equal to 0. LA is the phase inductance of A phase, and theta is the angle of rotation. So now phase A will be turned off, and B is energized, and then rotor axis BB dash turns to the stator axis BB dash, capital BB dash, and move clockwise as per our say diagram. And by changing the polarity of the motor, we can easily reverse the motor. The torque developed since the reluctance changes from maximum to a minimum. The developed torque is equal to half IB square d delta LB, and the rotor movement is depending upon the number of poles, and in our case we get 30-degree say rotation by energizing one phase at a time. So here torque is nothing but a rotor movement only, and when the shaft reaches to position B with us, then there is no torque, that is d delta LB equal to 0. So now B phase will be turned off and C phase will be turned on, and then the torque is developed because the rotor axis A dash is aligned with the stator axis capital CC dash, and the rotor continues to rotate for another 30 degree. So again C will be turned off and A will be started, and the motor operation continues until the input power supply. Here we can observe that the motor is rotating by self, and the switch reluctance motors are self-starting motors, and the control circuit continuously monitors the motor speed and input current, and if the motor speed falls with respect to the reference, and then the control considers as there is a requirement of high torque. So therefore it increases the input current to the motor to meet the speed requirement, and in case of the motor current is reaches beyond the full load current, it strips the motor. So types of the switch reluctance motors, it may be linear SRM type and rotary SRM type. So this is linear SRM type is single step stator and rotors, and rotary having more than one step stator and rotor. So this is the types. So switch reluctance motors, rotary and linear. So it is also called servo in the linear markets, and this is a rotary switch, so it may be radial field SRM and axial field SRM, and axial field SRM again single stack and multi stack. So these are the types, and advantages are it does not require any external ventilation system as stator and rotor slots projectors, and the airflow maintained between the slots, and rotor does not have winding since therefore no net keeps the carbon bus and slips during assembly. And since the absence of power magnets, such motors are available at a cheaper price, and a simple there are two phase pulse generator is enough to drive the motors, and the direction of the motor can be reversed by changing the phase sequence, and self-starting and does not require external arrangement, and starting torque can be very high without excessive induced currents, and high fault tolerance, phase losses do not affect motor operations, and high torque to inertia ratio and high starting torque can be achieved. And disadvantages are creates torque ripple at high speed operation, external rotor position sensor is required, noise level is high, and at a higher speed the motor generates harmonics, and to reduce this we need to install the larger size capacitors, and since the absence of permanent magnet, the motor has been designed to carry high input current, and it increases the converters kVA requirements, and its applications is in such as in washing machines, vacuum cleaners, fans, etc. And also we have shown you the animations of the working of this working basically of SRM. So once again I am showing you these animations. Let's see how with the say it is rotating in steps, that is 30 degree phase. So that's all about this switch reluctance motor for today's discussions. I have taken the help of some sites from the internet, and also the textbooks of say P.S. Bimra and Nagrat and Kotari electric machines, and Ashfaq Hussein's. And not only that, there are not many good books available in the market. I have given you in the bibliography the name of the text and say reference books as well, and you can follow any of this, and if you carefully listen my lecture, and if you try to understand it, you will be able to understand it very easily. And besides that, if you find any difficulty, you may as I told you in earlier, so you can contact me. So outcome of this discussions is that, so switch reluctance motors constructions, its types, its advantages, its disadvantages, and how it, where it is applied and how it works. So that's all. Thank you.